As you heard, my name is Farshid Sabat. I'm at Movidius. And the aspect I wanted to talk about today was vision processing in wearable and devices and smartphones. Many of you may not know much about Movidius. I'm giving you a little bit of introduction. I apologize for the commercial intro here. Movidius is a startup company. Many of you may not know the company, but has been around for more than 7 years. The principal goal of the company was to bring in high-performance computing to ultra-low power devices. The company has been around with a lot of funding, multiple generations of the SoC system on a chip that the company has designed. And the simple goal of the company is to bring vision, smart cameras to the new family of the devices. Where vision is coming from our seeing eye, why it is important for us, why is it that we want to make the cameras smarter for all the family of devices, is the inspiration is coming from us, from human beings. Our eyes, our vision has gone through more than 500 million years of evolution. We see that more than 95% of species have eyes. It's so important for survival and evolution of the species. We acquire more than 90% as human beings information around ourselves through eyes, through our vision, and we process those. A child as is born gathers more than 80% of the learning happens through the visual means. We all know this, we all have children, we're very familiar with that aspect. And more than half of our brain is consumed, dedicated, and is involved with the vision processing. Whereas the vision, human vision versus the computer vision still is in its infancies. And still the original scientists who came up with shape detections and object recognitions are among us, and many of you I assume that they are with us in this room. What we have seen, the goal of having eyes everywhere, I think some of you were showing some skepticism about whether Internet of Things or wearable devices happening or not. Many of us have been in when people were making comments that mobile phones will never take to these levels. And we saw that what happened to the mobile phones and other type of devices. I don't have any doubt that we will see a great explosion of the devices happening based on the connectivity, based on all the information that I gathered. What form would be, whether it would be a bra or a sock or glass or other type of devices, I would not know. But there will be definitely, this is the trend that is happening. In what we saw in the camera adoption into the smartphones, the inflection point, what happened that the cameras got adopted in the billion unit and above was primarily when the image quality that we were able to generate from the cameras were good enough that we did not need to carry our digital camera with us. And that function becomes such an important, a mandatory function for us to be able to carry a phone with us. The next phase, as Julia mentioned, and a lot of you are working on, is ability to the contextual awareness. In this sense, is the visual awareness. Instead of just taking good pictures or capturing nice videos, to be able to analyze our scene. This is what our eyes do, and this is what human vision is all about. If we can bring that level of visual awareness to to these devices, then we will see the great explosion of what can be done with this application and devices. In this aspect, there are two axes for the innovation in this area. On the bottom, you will see cameras are becoming smarter. A lot of great stride is going through this. Camera image sensor companies are doing enormous amount of work to reduce the power to the levels that make sense for these devices to get adopted into your next version of the Internet of Things or wearable type of devices. There are tons of work that is going on with inspirations from the nature, from our evolutions to do similar to the eyes of the flies that is compound eyes, to people creating cameras that are compound cameras. We call them array cameras in various different formats. And all the things that you could do with this to be able to detect depth, to be able to detect speed, to be able to detect many different visual information that is important for us and for Julias of the world to do the great things that the software companies will learn to do. On the left-hand side is the visual analytics, as you see on the y-axis. And the visual analytics is important for us. We see already, we can detect faces. We already see that the people measure how many people come in and out of store. But taking it to the next level of the things that can be done in the smart devices that we carry, or devices that's sitting on the side, a drop cam device that is on your house is recording your environment, for instance. So what happens in this sense, we will move from purely improving on the image quality of the camera, of the visual elements, which is always important because we have a perfect camera, our eyes, a mechanical camera, optical camera can never accomplish this. So this is an infinite goal. We constantly will improve it and we will never be happy with this. But on the other side is ability to make the cameras smarter and to cameras to be able to interact with the scene, with the environment in a smarter ways, to be able to gather information for us. The technical term, the folks in that industry call it imaging for information, rather than imaging for visual capture per se. Some of the examples of the work that is being done, and I'm humbled by some of the folks that some of you are creating these applications, are many different, very interesting applications. There's one of the areas that is very exciting is what is known as computational imaging. When you add a massive amount of computation with image captures, all the great things you can do. You've seen some of those happens in all the smartphones. You see every generation of the phones are having no features. You have high dynamic range to be able to take pictures at more harsh environments. You can take panorama ability to be able to do the next version of it that you don't have to follow the red line. A lot of different work that is done in this area in computational imaging. That's just, we're scratching the surface as far as what can be done here. A lot of smart work is done. Second area that is becoming very, very exciting in the last 9 months or so, ability for us to be able to use our phone or any other camera to generate a 3D model of what is in front of us. They call it 3D scanning and modeling. And part of the motivation of this is driven because our 3D printers have come to the prices that are very affordable, and people can do a lot of creative things with this. So you can actually, these are the kind of things that people want to make that happen. Other areas, we've seen what the search has done for us in terms of simplifying our lives, and the ability to bring with this smart cameras to be able to improve the concept of the visual search. And that could be for a purpose of commerce, or finding an object, or what you've seen Google is showing in terms of going to a library, going to a museum, looking at the painting, get the information from this. There are tons of other applications to do with indoor navigations, to do with augmented reality for educational purposes, for medical, for many other interesting applications, as well as for ability for the camera to be able to read gestures, and based on lip reading or face reading, to improve concepts of such as Siri or Iris, if you're familiar with one of those environments, to improve even the voice recognition by reading your lips. So at the core of this vision processing is three elements. At the basic element is image quality. You have to be able to generate decent image quality. The technical terms, ISP plus, image processing, but ability to be able to control the smart people yourself, that be able to change and design your image pipeline according to what you need to take the best pictures or be able to add new capabilities and features. Second areas is computational ISP, and that's when you have multiple cameras or you have multiple ways to be able to get information, and how we stitch these together and create the enhanced experience. As you know, in the past 100 years or so of the photography, every picture we take is flat. We take the 3D world, we flatten it in a 2D object. Every picture, the most beautiful picture you have seen. But the work that folks are doing is that to create a three-dimensional element, not necessarily for the purpose of creating avatar of 3D movies, but having depth allows to why computers are not as good as humans to be able to recognize things, because if you don't have depth, you don't have ability to be able to identify the second row from the third row, and one object from the other, segmentation element and others. And then the third area for us is the computer vision. And computer vision is a large field with infinitely complex problem. To be able to, you can take any of the digital cameras or any of the phones today have ability to be able to do a face recognition. That's a very simple thing to do. But ability to turn it on all the time, and in extreme scenarios, extreme lighting, when the object is moving, that's a difficult topic, for instance. And many, many different classes of problems of that nature. The other area that is very, very challenging, as Reza mentioned earlier, and this is obviously if vision is going to get exasperated, is the power. This is power, obviously, for any of these devices, a never-ending story. You know this, I don't have to explain that to you. But because always the smarter people putting more and more load and application on top of these devices, and the demand it's always on the rise. But this problem is going to get more challenging when you have cameras involved. The fastest component of any of your smartphones is the camera input. You have 8 lines of multiple gigabits are running to be able to capture 13 meg or 16 meg in a Galaxy S5. And you always have that problem of power. So now, bringing it to the devices that have even more battery challenge. You know, we see that the battery capacities of the phones versus the tablets, wearable devices are in the extreme end of this, right? So what is required, extremely low power computational device to be able to make this happen. So what we have done at Movidius, and many other companies are doing very smart things as well to do with these areas, our approach is the 3 pillars to solve the vision processing problems. Number 1 has to be high performance architecture that allow to solve the complex problems of imaging and vision. Number 2, it has to do it at extremely low power. Ultra low power is extremely important. And number 3, it has to be programmable, because the nature of the problems we're trying to solve are not fixed function problems. There are problems that based on the environments, based on the conditions, requires programmability and changes. So just to put this together, you probably heard about the announcement of the Google Tango project. This device is a smartphone device. It uses multiple measurement units, 9-axis, barometer pressure sensors, and other sensors. Plus, it uses multiple cameras, front and back, and to be able to accomplish various computational imaging, various vision processing work. In this example, they're using 2 of Movidius' previous version of the vision processor. So some of the examples of what they have accomplished, this is the first device of its kind in its form factor. You'll see that it can ability to do an indoor mapping with accuracy with vision. And their belief was that you cannot always assume that you have a radio signal. You have to augment that ability of a radio signal with the camera visual input from the camera. The sensors has motion tracking, and the visual processor will take care of that. ability to be able to walk you through a mall and directly guide you to a specific location where the store is located. The second application of its kind is in the immersive gaming. A lot of smart gaming people are creating applications that with wearable devices, glass type of devices, or smartphone or tablets, people can interact with their environment. Very, very innovative and interesting, mind-blowing games. I already have a hard time taking my tablet from my kids, playing some of these games. Imagine with things like this, we are making our kids are more bound and prisoned to their tablet devices. The second category is what the device has, the ability to do a 3D depth map and creation. So with the accuracy, it can generate information and scan information that we can measure the distance from the second row to the first row accurately. We all got some of the applications in the retail stores are planning. You go to Home Depot and you can measure by having the app, interacting with the Home Depot app. You measure the carpets in your room, press send button, order that the size of the carpets, the colors that you want come to you as well. So as I said that, there are a lot of interesting companies that are doing some very creative work with that. There's a company that is generating for real estate type of businesses with this device, a 3D dollhouse of the properties. Remember that you have to take previously 360 views of the house. Now you can actually with the phone you can scan the house and create a 3D rendered model. The picture you see is a rendered model. It's not a picture. You can go in and out. There are some other very creative folks are creating applications that you could services that you could 3D model, generate a 3D model of your apartment and send it to your loved ones, to your grandparents, to your kids, and they can actually walk through that and experience it with having with just a phone. The opportunities are limitless in terms of what are being done with this device and what people are doing with it. At the end, I wanted to my point here. Wanted to summarize it that smartphones have been a major driver for adoption of the camera usage and the vision applications. Vision applications are being adopted by many of the consumer, mobile, industrial, automotive applications, and I have no doubt that the wearable devices will take the advantage of all the innovations that is done in the mobile phones, smartphones, and tablets, and for the application that it makes sense, they will be adopted for those environments. This is, I appreciate the opportunity to be with you, and thank you very much.